Yes, friend. Now we will go to other topic. I mean, subtopic. It's a compression ratio. So, anyway, let's come here. Okay, this is good. Please, let's speak about that. Now we'll write again. Let's start. Let's say we've claimed that run length encoding. Claimed that run length run length encoding can some can some I think save us, right? Sorry, can save us space when storing space when storing simple images, when storing simple, maybe we can write there simple, mm, anyway, simple images, but how much space? This is the question. In this point, I want to do one thing. Let's come here, take this frame, put it here, like maybe that. Yeah, I think it will be good. Then, right, let's come little down. Now I want to do here something. Let's start here. Say image. This is image. And this is dimension. Okay, dimensions. And compress it. So this first point, and say after run length encoding, after RLE, and say space savings. Okay, what we have to do, now, let's take this one is left. Maybe we can do little big frame. Let's see frame. Yeah, right. I think this is good. But anyway, we're going too much. I think we did. Yeah, let's come little to right. Little left. Okay. Space saving is some good point. Let's come little right from this place. Yes, I think it is good. Now, let's take here one line to make this thing here. This is good. Oh, this is not linear. So not, I mean, let's go a little left. Like that. So let's take it little. Let's take little down. Still, it's bad, but I don't know how to solve this problem. I think it is good. I'm not sure. I'm just looking there if it is good. Anyway, then we have images, but before images, what I want to do, I want to take this frame little down this place, and then let's start to put these images there. Our first images, let's go file. The first one is 6 PNG. This is T. Yes. Now let's go Doland. The sixth PNG, where is it? Let's come here. The sixth PNG is that. Then we have seventh and eighth. Eighth. We have seventh here. And we have eighth and right here. Okay. Let's come. So this one is first. Let's say this is here. This one is like here. And this one is like here. Maybe we can tag this dimension and things little there like that. And let's place like between them. Yeah, I think that this one is in this point good. So you know what I'm doing, right? Yeah. This is the last image. And tag this one there and here. This one can be in here. Maybe image. No. Let's come back. Yeah. Let's say image also here. Maybe a little more, right? Okay. Okay, just you can think like that, okay? This is not too much difficult. Let's start with it. The first one is 16 by 16. And compressed time, it is 256. We know what is it, right? It's tagging 1010 and lots of bits to representing it the same thing. So we know, right? Like white, black, white, black. But when we compress it with the after run length encoding, it will be different. It will give you different solution. Like what? Now you will see with me. After run length encoding, it will be 228. Okay. And space saving will be 10 10.9 percentage. So just think, uncompressed time, it is like 256. There is white, black, white, black. If you go in detail, you will see again, we spoke about it, right? For the 16 by 16. But when we compressed it with the run length encoding algorithm, it is will be so it will give us 9.9 percentage, so percent space saving. Come here. This one is 32 by 32. This is will be 1024 and compress it time. It's like, again, I told you white black, it's all the time and compress it. So we are not saying just think there is 15 5 color, but we are not saying 15, we are not writing there 15, we are just putting there 15 time white. Okay, 15 times 0, like you can think 0 0 0 0 0, we are doing that. But if we compressed it with the run length encoding, we are just saying 15 for that. Okay, after run length encoding, it's coming like 12, I think. So closer, near to half. What do you think? This is amazing, guys. So you don't losing any quality from your image. This losing, so losing compressing. There's we have also lossy, but we are not speaking about losing. This is 48%. 8%. Last, this one 128 by 128. So 128 column, so 128 rows, 128 columns. Then we have some each pixels there, and we just uncompressed time. It is 16,384. 16,384. 384. After run length encoding, it is really amazing. This is 2,898. This is amazing saving. Just think, friend. You have 128 rows, 128 columns, and there is just you can multiply these numbers. You will find solution. There is we have black white, lots of black white. So you can think like this place is whites and this place is black. Just we are just saying, just you can think in this point, maybe we have here 15 black and 15 black here, then all others, so except of this blacks, all of them it's whites. So there is maybe 100. So if you think totally it's 128, just say 28 we have black, or 30 black, then we have just 100 white. So we are not going to say white 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 0 0 0 0 like that. We are just saying 100 like that, finish 100. We are just saying 100, and if we have black 30, we're saying 30, and it's all. We are not going to say 0 0 0 for represent white. Just we are compressing it with the good algorithm, I mean run length encoding. This is good for icons, for white and black things. This is not for all colorful things, because if we have colorful things and we have too much details. Anyway, so in here, in this point, we say 82.3%. If you ask me, this is amazing, really. This is very good, really. Let's come down. We will write now things here. But if you think, if the things growing, so I mean if the dimensions, columns and rows is growing, then our saving space is coming more. Because if the image dimensions, I mean just saying it if it is like 256 by 256, it will come lots of good space. So again, we will save lots of space there. Sorry. Let's come here and we will write now. Take a look. Take a look. That final column. The space savings. Mm, yeah, here maybe I can drink little. Space savings. Notice a pattern. Yeah, you have to see. We save much more. We save much more space as the size increases. As the size increases, not increases. This increases. Since the runs are much longer. Yeah. What about images of the size of the same size? This table. So just think, we have different images, but they have same size. This table summarize. Mm, yeah, summarizes the results of compressing three large icons, three large icons with RLA. Yeah. Now what we will do here, I want to do one thing here. I will tag all of them, this all information. Let's duplicate them. Bring down. Yeah. Let's go a little up. Now our icon will change. So all icon will be bigger. So what I'm saying, now you will understand better. Let's say that's delighted also, and I think the first one is same. Let's come 9 images, 9 PNG. I think this is same. Yeah, same size. Let's delete it. The first one is that. Okay, just things will come little down. These things. Now I will edit here this place. Give me time. And we have where is the tent? Yeah, also we have tent, and we have 11th. Where is the 11th? 11th tent. I'm looking for 11th right here. Yeah, let's come down. Now what I want to do here in this point, we will do something together. Let's tag it there, and let's tag it down little. Yeah, and just things will change here. Let's give me time to solve this problem. Let's take this down and let's say, yep, let's delete all of them. Yes, let's take it here. Let's come down. For this one, this is again 128, 128 by 128, and compressing here, again same like this, but after running encoding, things will be different. So it will be 49.4% saving space. Because why? We will speak about that. 98. After run length encoding, it's just decreasing the displays. So it is just compressing it like that. So it is 49.4, 49.44, and put that there. Let's write other one also there. Mm. Now I will speak about it, but just wait me. This one is last one. It's just again same 128 by 128. Again 16,384, and after running encoding it is little more, maybe like, yeah, and just we we saved space here only 64.7%. Yeah, let's come in detail. Now you will think why it is like that. We have same dimensions, we have same uncompressed values, but why different round length encoding and space saving? No, the important point here that we have here lots of white, right? But what we are saying for the white is representing 0, right? And black representing 1. Of course, like that, right? Now, if you think here, why things is different, just wait. It's just like you don't going to write there too much 0, 0, 0 again, these things like that. And just you compressing with the some way. But if you look the third and second image, so second icon here, there is some details, I mean, inside it, okay? So you don't have chance too much right there, something like 15, 30. All the time you have to give some details, and it's coming up, I mean, after running encoding. This is the key point here. So in how it's, if you look, there is lots of places in so training, I mean, during the staying next to next, I mean, too much nearly, okay? But if you look other images, there is too much white, and whites, always starting uh, with the numbers of whites, and if the things is starting with the black, we say 0. So for this point, anyway, that's all. So just you have to know this information. Up, let's come down, and let's say here, yeah, here. Nope, you can see why I pick it, why I pick it. Uh, icon as my example. It compress very well, very well. So uh, thanks to its many runs of black or white. So RLA compression is RLA compression still halves the size of the size of the size of the other icons, but it doesn't save, but it doesn't save, it doesn't save nearly as much space. And in fact, in fact, sometimes, sometimes RLA can't save any space at all. Space at all. Can be sometimes, you know. Yes, let's come down. Let's say the new subtopic limits of limits of RLA. Let's do it this color. Yeah. Let's start in this place. What is the limit? How about this? How about about this 16 by 16 icon? Now I will bring this icon here. 12th PNG. Where is the 12th PNG? This one. Yeah, it's just there. Try to see it. Yep, here. Let's, if you want, I can I can go in detail, but I will show it, you know, all detail. Don't worry about that. There is, yeah, this is a little crazy. Anyway, let's try later. We will speak about that. Let's come here. Yeah. Now, there is, have you seen there is too much color? In German, they are saying bunt, colorful, I think, something like that. Now, say, let's zoom in so we can visualize, can visualize each pixel. Yep, we can do it right now. 13 changes. This one, it will be bigger. Yeah, this is that. But let's little small it because it is too much big. Let's make it like that. Maybe we can do a little bit more. Normally it's bigger, but just I'm doing for give you example, I mean. No, 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 no. Oh, what happening? It's crazy. It is very crazy, really. I don't know what I have to do in this point. Let's make it small like that. Yep. Let's put it there. Okay. And let's go there. Okay. This is the point. Okay. You can understand like that. Let's come left little. Okay. Let's make little light. Zoom it. Yep. It is that. The first one, you saw it, right? Mm. Really, it's making me crazy when I interest with the editing things here in Figma. Normally, Figma is better, but I'm not using too much Figma in my life. Let's do it. Okay, this is some details inside this 16 by 16 icon. So exactly, we are looking in this. So we just zoom it. Okay, we just visualizing it. If you see, there is lots of color, right? Then how you can compress this? This is not black, this is not white. There is too much color have. And so it has too much color. How we can solve this problem? How we can do? We can't say one blue, one green, one pink, and really it will take lots of time. Okay, run link encoding not working for it. Okay, so exactly, it will be a problem, of course. Let's come right, little, yep. And now we will start to right again. Let's go a little left, yep, like that. Let's start to right. In this point, we will say maybe in, let's come a little up. Yep, here. Let's say each pixel in that icon, in that icon is a different color. Is a different different color, and there are neurons, right? Run length encoding can't compress an image like that at all, as it turns out. Photographic images are mm, photographic 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 images are photographic images are similar to that similar to that icon. The real world real world is uh, fill it with details, right? Fill it with the details that interrupt that interrupt runs. Yeah, this is too much important. Now we have lots of details. Anyway, let's say. Also, I want to say I got an image from an academy. I love this Khan Academy. Really, I learned lots of stuff there, and I love Salkan. Thank you so much, Salkan. I'm just, how I can say, I just like to share all my information with what I learned in Khan Academy all the time. I'm sharing in YouTube and in some way. So just I'm learning from there too much things. Khan Academy. So it's so amazing photo of dog looking at computer looking at a computer screen. Yep, let's look at where is that? Let's come down a little. 14, this one here. Yep, this image, amazing image. So in this point we can say, let's do it a little small, maybe, if possible. Yeah, let's say yes, at normal resolution. No, yeah, at normal resolution it looks like there are it looks like there are blocks blocks of similar color, like in the dogs dogs so or the gray in the computer screen, the gray in the computer screen. So what I'm saying here, look at that. It's in the computer screen. It's something looking like this point. I mean, something look like in this point. Something look like gray, right? And also in the dog, there is something looking like in the I mean, looking like same color, similar color all the time. But it is not that. If you go in details, let's try that. Have you see? There are uh, lots of color, different color. Now we are if you look this keyboard, we will see all the things is looking like white. Let's go in detail what we have in the that one. Yeah, this is keyboard. Have you seen this? This is looking like black or a little bit different, not white. But if you come back, now you will see this is looking really white. This is not black. For doggy, it's same. Let's go in doggy. Now you will see there the all color is not really like yellow or something like that. I told you. Let's come left. Yes, I mean here. Let's go up right here. Yes. So now I will show you other image. It will help us to understand. Yeah, this is the image. Now we are looking here. It's just zoom the first one. So I mean that one is just we are looking this point from doggy. We just zoom it. Yeah, this point. I mean this is the zoom. Have you seen lots of different color? Colorful, there is black and different colors. That's okay. Let's come down and say, let's say, mm, tag pencil, and let's come down. Let's start right now. You can see that even. You can see that even. The seemingly simple, the seemingly simple computer screen is a computer screen is a vast array of similar vast array. So it is not like that. Is a vast array of similar but not quite the same colors around around length around length encoding of the pixels. Yep, of the pixels won't won't do much to reduce the file size file size. Yes. So yep, this is that. Let's come here and say uses for RLA, run length encoding. Yep, let's come down to here. Let's say RLA compression was a very popular, very was a very popular was a very popular technique when must computer images technique uh, technique when most computer images were icons icons with limited color palettes color palettes palettes. Yeah, just think if you have their two color, then we can use running encoding. But if you have more than two colors, it is really not possible. These days, our images are more complex and don't don't contain don't contain as many runs of the same color. So say where is RLA used today? Good question. Fax machines still use use RLA for compressing compressing faxed faxed documents. Yeah. Since they only need to represent since they only represent since only they represent only need to represent not only they since only they only need to represent right black and white letters black and white letters. So pack images you use RLA during during a final stage during a final stage of compression compression but they first use but but they they first use a more complex algorithm mm, To compress the photographic, to compress, to compress the photographic, photographic, photographic details. Yep, we'll explore that more soon. Okay, now our other topic will be lossless bit compression. Then, yeah, then we have practice questions, and it will finish. Then we will go lossy data, data compression, lossy compression. Now we are speaking all the time about. So we processed in this progress time all the time about. We spoke about lossless compressing. Now we will later of all we will speak about lossy. Okay, it's okay for now. Now let's go to other topic, lossless bit compression. We will continue from there. Okay,